Wonderful. So we are on air. Hello, Jeff. And we're speaking today to Jeff Rogers, who is the Global Research Leader for Digital Health at IBM, as well as Distinguished Scientist, as well as probably 10 other titles I'm not aware of. Jeff, welcome to this podcast. And let's just start with you telling us, what do you actually do at IBM?
Good morning, Natalie. It's nice to hear from you again. At IBM, my role is to do a couple things. One is to organize the company's efforts in what we term as digital health. So that means how we bring together innovations in electronics for sensing and things like that, information technologies like artificial intelligence and other simulation tools with large computing and networking. So how do we bring together all the pieces of information technology that we have today to innovate in healthcare and wellness, right? So we want to think about how do you prevent disease from ever getting started? And when it does get started, how can you use modern tools to actually help improve their treatment and help them get a better outcome?
Jeff, and what is it that you're currently working on? What's your most important project right now?
We have IBM and my team have a large partnership with Cleveland Clinic now, where we've tied up over the next 10 years to take advantage of new ideas in computing, like quantum computing. And Cleveland Clinic has installed one of IBM's quantum computers, the first dedicated quantum computer for healthcare. And they're working on their research side. We've installed that, not my team, but the quantum part of IBM has installed the quantum computer there. And then my team is working with researchers and doctors at Cleveland Clinic on, a variety of things, from how do you capture when people are having an epileptic seizure and then grade it, because that's very hard. Today, what you ask people to do is take a pen and paper and fill out, I've had a seizure and how long it lasted. But the problem with that, of course, is that a seizure, by definition, is an alteration of the mental state. So you're asking somebody to write down an experience where largely they can't. So how can we use digital health solutions to actually pick up a seizure has started, how long it lasted, and what type it was? So that's an example of the things we're working on, but we're doing other things in diabetes, in Crohn's disease, in infants with malformed hearts that have low cardiac output. So a range of projects we're working on with Cleveland Clinic. That's something that I find that's really exciting right now. And then the other thing that I find that's very exciting is other projects we have going on with other partners around, neurological diseases. It's a lot in the press a lot how dementia, various types, Alzheimer's or Lewy body and other things are actually becoming a growing problem. So how can we predict the onset of this in advance, because there are now medications that can slow progression by 35 to 40%. So, we can move neurological diseases like dementia into the chronic disease, as opposed to we're just watching you deteriorate. We're going to tell you how long it's going to take. We can now start to treat that. So for that to be successful, you have to pick up that somebody's beginning to transition and then get them on the medication and give them proper dosing, because there's bad side effects. Sometimes side effects aren't a big deal. These side effects are. So how can we give people the proper medication for what they're dealing with, and as early as possible? So that's a place where we're really focused.
That sounds extremely promising and exciting. I still am trying to find the link to what you guys do in fitness and wellness. How is this connected?
Oh, okay. Sorry. I should have touched on that a little more. So certainly, we focus a lot on disease. In no small part because there's a defined state and the progression time frame is relatively short, often, right? And so we can know whether or not we're successful pretty quickly, but we want to prevent disease from ever getting started. So fitness is thought to be, and I say thought because it's not actually worked out, is thought to really affect health, long-term health, okay, and improve it. So what we want to do is understand when a body is working well, how it is injured when it is, how it recovers from that. And that gives us a whole different window into what it means when somebody's diseased, right? So if we understand the health perspective, that lets us look at disease in a different way. And we can bring the two together so that we can actually achieve the goal of prevention of disease. So that's going to require having to do with health.
Mm. And how is AI integrated into your efforts of disease treatment and prevention? Tell us a bit more about that, please.
Yeah, so artificial intelligence, one, is badly overhyped. However, what it does that's amazing is that it allows you to deal with very noisy data and to find correlations between things that you would never see another way, right? You simply couldn't do it. Now, correlation is not causation, right? Which means, that just because I see a correlation between two things doesn't mean they're related. Even if the correlation is strong, it can be, and often is, just coincidental, or somebody used the AI techniques wrong. So, we focus on how can we take advantage of artificial intelligence, because it allows us to deal with noisy signals, and they're always noisy from people. And then also it gives us, especially with language, it gives us new capabilities, right? So the ability to actually, and this is something we're doing right now, Natalie, that we're excited about. The National Institutes of Health in the U.S. has funded IBM, Mount Sinai, and Harvard to look at kids when they come into the emergency room who are at risk for psychosis, right? So that time frame when you're an adolescent becoming an adult is when psychosis actually gets started for a lot of people. So kids come into the emergency room in a crisis, and we're actually using speech from them to assess, are they transitioning towards schizophrenia or mania, or is this something totally else? And what's interesting is, the way the mind generates language is a wonderful window into how it's functioning, okay? And so people who are transitioning to mania begin to use the personal pronoun on everything. So they will be, or they never use it at all.
Huh.
And so this is a signature that actually, and they have a flight of ideas. So they start to go through all these ideas, and they make basically a flower in an embedding space. And so we can get that out of just a couple minutes of language. So what we're trying to do is show, and the NIH in the US is funding us to demonstrate it at scale, because we've done it in clinical trials, small ones. So now they want it at scale. So AI will give us the chance to actually understand the language they're generating, right? And basically say, this is a person at risk for psychosis, or they've already transitioned and you have to get some services behind them. So that's an example where I think, it does something very unexpected. And, the large language models that have developed, language has some very special characteristics about it. And it's really amazing the insights you can gain, because you can evaluate someone's mini mental state and then use that evaluation of their mini mental state to actually understand, is this a person who's having a psychotic event or not? And then that allows the doctors to treat them more successfully and spend, a lot less time trying to get a handle on where they're going.
There's useful part of AI, there's overhyped part of AI as well.
Yeah.
And you also mentioned that medical chatbots, in your opinion, are purely overhyped. Tell us more about
Hold on
medical...
now. I think what I want to say is that, there has been great advances recently in chatbots, ways to interact with AI. Okay. And so those chatbots allow anybody to, basically type in a question to an AI and get a response, which is amazing. But you got to remember, it's not intelligence, okay? No one has achieved general intelligence with AI, and we're not about to, right? So claims to the contrary are marketing, in my opinion. So some very big name people are making some claims that just seem to be coming from a fantasy land, right?
Let's not name the names.
Yeah, but the reality is that there's been great advances here, but what the engines do still, right, is that they put together a word and say, the most likely next word for a certain goal is this, and then this, or, a sentence, a block of words most likely look like this. Now that can convince you that, something's intelligent, right? But, people should look back into the 1960s when we first thought that we had achieved general intelligence. Okay.
Well, you have the Turing test, you have the Chinese room experiment. It depends on what you
And they
define as
fail, and the ones
intelligence, right?
today fail that stuff, right? But almost anybody doesn't actually apply the Turing test to their AI to figure out if it's right or not, if it's actually thinking, right? There are some publications out now who have done it, and they have shown that these ones are not thinking, right? What they're doing is they're putting down random words. It's exciting what it can do, but the
How
danger.
do you know that you're thinking?
Well, I'm sure there's a number of people who'd say I'm not, but I think you can pass the Turing test. So it's an important question. I don't mean to be flippant about it. I don't know the answer to it. But the interesting thing is that when one of these things has what we call a hallucination, it picks a set of words and now it goes off on a tangent. In a healthcare situation, you can't have your medical chatbot doing that, right? Because if it starts to give, a suggestion, which seems convincing, because all of them seem so convincing, and it's just completely wrong, right? It could have some really bad health effects, right? That could kill somebody. So that's a focus in the U.S. for sure around having, from our ARPA-H agency, actually has had call for proposals, and they're working, actively funding programs to try and beat down the hallucinations. But I think the most recent advances in multi-agent AIs will allow us to actually fix that problem. So I'm hopeful that we've actually already found a solution. But what worries me is that, people, because it's easily accessible, they convince themselves, oh, I understand this, I can go and do it, right? And what they don't quite understand is how it can hallucinate, how to really work with it properly. And what they end up is putting themselves in a situation where they're going to provide something that looks like it works, but it doesn't. So you have to test stuff, and you need to work with people who understand artificial intelligence, not just at the superficial level. And sometimes often medical experts don't, and they'll be convinced this is amazing, I'm going to go use it with patients, right? So it needs to be tested. That's all.
So this multi-agent AI, can you bring some very specific examples how this can be used? First of all, what is this? And second, how can this be used in the context of wellness, fitness, consumer health?
So the basic principle of a multi-agent AI would be any one AI might hallucinate, but you use multiple AIs with the same task and allow them to interact with one another. And then collectively between the group, you come up with what your response is going to be. Okay. And so this is a way to work around the whole idea of hallucinations, because if any one AI goes off on a hallucination, the other ones, and you want to use different models. Okay. You don't want to have the same model all the time, right? But you can use different models and allow them to interact. And then we're moving into the domain where I think people are beginning to appreciate, and certainly where artificial intelligence is going, is that, these gigantic models where you suck up all the data in the internet are, one, not a good idea, because you don't, you're kind of building in some crazy stuff there in the process. And then the other idea that people realize is the computational and memory resources are significant, right? So if you want to field it and you don't have a big data center behind you and you don't have strong connectivity, you might want just a fit for purpose AI, right? Which is a much smaller model that has a particular goal, but still gives you all the capabilities you're after. But it's just a fit for purpose one. It's smaller, easier to compute. So building those fit for purpose AIs, foundation models, right? Fit for purpose foundation models, which you can then tune. I think that's a great way. It's particularly wonderful in healthcare and fitness because, you don't have to have 100,000, 1 million people you train on. You train on a relatively a huge set that is not in your disease area or in your healthcare application or wellness application. And then you tailor it with a much smaller data set that is specific to your case, right? So that means, you could work with 100 individuals, where in the past that would have been a nonsensical number, right?
So you're speaking about fit for purpose AI?
Yes. And then multi-agent AI, I meant to cover that in my initial comments about, you use the multi-agents in a dialogue amongst one another. But the other direction that I think is exciting there is around fit-for-purpose AIs.
Give me some meat. So how can, let's say, a wellness app, a fitness app that's very much on the lifestyle side of things, not that much on the disease side of things, can
Right.
use these models specifically as a couple of ideas to provide better value to their customers?
Okay, so in the fit for purpose one, right, in the foundation models that are built for a particular purpose. So let's say that you want to monitor someone while they're doing rehabilitation. Okay. But you want to use an AI to track their motion, right? And understand, are they able to extend their arms as far as they're trying because they injured their shoulder, right? Or trying to, reach a certain flexibility. And so we want to see if they're doing that. So currently an AI model you build to do that would be based on the particular cameras you're using to image and their location. You have to build it for the setup. You have to build it for the particular configuration you're using. All right.
That sounds like EGM Genius.
Well, that's what you have to do today, right? But with these foundation models, the idea would be you actually work out a whole bunch of different configurations in the foundation model, and then it's not dependent on a particular configuration. So you could allow someone, instead of having a rigid setup in a training facility, you could just set up a cell phone somewhere and actually get a valid model of them just from the cell phone, right? So break the dependency on the configuration and everything by using a foundation model.
Right. I feel there's quite some things that are already happening in this space, and I'm very excited to see where we land moving forward with this kind of
What
models.
are those? What are in this space? What do you see?
Well, I'm not sure if this is like what kind of model that corresponds to, right?
Okay.
But already several years ago, we had Vey, which was a Swiss company that exited to Nautilus, that is the manufacturer of equipment for home fitness specifically. And it was about movement tracking and movement recognition for rehab, for fitness training as well. And there are quite some other companies out there like Zinc Coach that also integrates AI for as computer vision on your phone, right? So it seems that you're speaking about similar things, and that's interesting to see where the differences would be. But for that, you probably need to dive into the code.
No. I'm sorry. What I'm trying to say is that the performance they get using traditional methods, deep learning or any of those techniques, is inferior performance to what you would get with a foundation model. Okay. Because their models that they use from deep learning are dependent on the camera setup. Whether they can try and mitigate that however they like, but they are. And so the foundation model would allow you to include all these different configurations in it. And there's not another that you couldn't do that with the deep learning approach.
Right. So it seems like the foundation model also allows us to think about new business models as well that are connected to the technology. What's the most exciting business model innovation that you see in the space moving forward with those models?
Wow. Okay, so that's unexpected. Business model innovation. I think a separation is occurring, right? Where you're seeing, instead of people supply an end-to-end solution, right? Where they give the whole integrated approach, right? From the core compute through the AI model to the solution. I think what you're seeing is a separation where some of these companies like Meta or even IBM, where I'm at, we have the Granite models, a line of foundation models. We're providing those foundational models, right? They're called foundation models, but we supply these big trained AI models, and then people can tailor those to their particular application. So there's now a business where they don't have to go and try and compete with whoever, Meta or OpenAI or IBM or anybody around training the core model. You can pick up that model and build your business on training it for your particular application. right? So I think that separation is an interesting set of business opportunities that haven't been there before. So if you're a smaller company, you can actually build on all this infrastructure without having to try and take on all the compute and all the expertise that went into that. You can tailor to your business much more effectively. So I think that is
Jeff,
an interesting thing, that separation.
yeah, it's interesting. And Jeff, thinking of emerging opportunities in AI on the technology side of things, on the business side of things, on the healthcare side of things as well, in the next couple of years, what are you most excited about?
So I think I actually, as critical as I would be of the medical chatbots, I think that's a place where we can really have innovation, right? It will surprise people, but in the end, just like in fitness, in healthcare, an awful lot of the follow-up is not quantitative. It's a survey. You give people surveys, right? And you call them on the phone and you ask them, how much pain are you in, right? And it's a number. Give me a number from 1 to 10. And then treatment is guided by that. So I think that an innovation that's coming that we're going to take advantage of soonest is actually going to be those chatbots interacting with people and being able to pull out insights that you simply can't get another way, and yet hold conversations with people that are empathetic. And I have watched people under treatment, actually not everybody, but there's a handful of people, a percentage of them that will actually really enjoy talking to chatbots. It's they play with it, and some people actually use it like a therapist, right? And so that's where there's going to be the earliest innovation. There's already innovation around continuous glucose monitoring, and that's for both fitness and for people with diabetes, right? And so that's going to continue. Those AIs are going to continue developing. But that's a very simple one. The one that I think will be complicated but have a very big impact is in actually interacting with people and facilitating a more insightful interaction.
Right. And what's the most underestimated trend that's coming up that no one is seeing yet?
I don't know. I mean, people are seeing a lot of stuff. I actually do think it's related to artificial intelligence, but not in it taking over the world or doing any such thing, right? But much more around giving people a way to interact with things, to write, to get through their day, right? To schedule things, to understand in the fitness regime, how do I get better? Or, I have this goal. How do I get there? How do I lose weight, right? But actually having an AI that would help you get over the little things about your behavior that prevent people from doing it, right? People needing immediate gratification is often what it is. And I do think that there's a chance for those assistants to be something that allows us to actually do amazing things that have always been a problem, like, losing weight or taking medication regularly or managing, blood pressure, these things that would, really help out. I think that that's where there's a chance.
As usual, behavior change and healthy habit formation.
Yes, there you go. That's a much better way to say it. And I think that AIs offer us a way to do that, which we haven't done in the past. So and also the idea along those lines of, a lot of people have mental health needs, and there just simply is not enough of a resource to address it. I actually think AI and, things like cognitive behavioral therapy, the idea that you could do that on everybody's phone and give them a way to really get more balanced. I think this is an opportunity that people aren't seeing enough.
Amazing insights. Jeff, thanks a lot.
Yeah. Take care, Natalie. Good to talk to you.